I've been using the Bambu Lab A1 for about a year now, and overall it's been a very reliable machine, and it's stable and easy to use and offers all the essential functionality that you would expect from a beginner-friendly 3D printer. That being said, there's one aspect of the A1 that I found really disappointing: the built-in camera. At times the camera feels more like a decorative feature rather than a practical one. As you can see here, this is the actual live stream from the printer, and the image quality and frame rate are extremely poor. And to solve this problem, I decided to build my own solution. I used the Raspberry Pi 02W and paired with a Raspberry Pi HQ camera to create this monitoring system. And I also assembled the camera case using free community-made STL files to keep the camera protected and firmly in place. And I will share the links to these STL files I used for this setup in our today's video description. And since the HQ camera uses a standard 1/4 inch tripod mount, which means it can be attached to literally any compatible tripod or mounting arm without the need for any additional parts. And to test the camera, I placed it next to the built-in A1 camera in a position where both can clearly monitor the printing progress. And a micro USB cable for powering the Raspberry Pi Zero routed into the printer enclosure. And to compare it with the built-in camera, I opened a live preview of both the A1 camera and a custom camera on my phone. And as you can see, the improvement is obvious. The video feed is smooth and the frame rate is consistent. And frame quality is also significantly better, and there's no lag, just a stable, real-time live stream. And on top of that, the camera can also be accessed remotely. Using a VPN connection, I'm able to view the live stream from my phone even when I'm outside. And here I'm actually on a train, and the video quality remains the same as it is at home. And even if you don't own a printer and don't specifically need print monitoring, this can still be used to securely monitor your home. Since the access is through the private VPN, the camera is not exposed to the public internet, and is fully controllable, customizable, and built with privacy and security in mind. To build this camera, firstly you should insert your microSD card into your laptop and then download the Raspberry Pi imager. And open the imager and select the device as Raspberry Pi 02W. And since this setup only requires camera access and no desktop needed, we navigate to other OS and choose OS Lite with 64-bit version. And after that, your SD card storage will pop up here, selecting continue. For the host name, you can use whatever name you prefer. In my case, I'm using A1-camera. And then select your time zone and regional settings as needed. And next we create a user account for our connecting to the Raspberry Pi. For simplicity, I'm using my name as both the username and the password. This is not recommended for long-term security, but it makes the initial setup much easier. And then we enter our home Wi-Fi SSD and the password and go next. For remote access, we'll use SSH with a public key authentication. And if you haven't generated a key yet, you can do so using the terminal. So open the terminal and paste the following command. And this command generates a new SSH key pair. And you can also find a snip of code in GitHub's documentation, and I will leave the link in the video description below. And next we choose a file path and a name for the key. So here I'm naming the key with the name A1 camera. And as for passphrase, I will leave empty for a simple initial setup. And once the process is completed, you will see the message that our public key has been saved as a1camera.pub. And now open this .pub file using any code editor and copy the entire contents of the file and paste it into our SSH configuration in the Raspberry Pi imager. and we won't be using the Raspberry Pi Connect, so we leave it off. And finally, at this point, review all the settings and to make sure everything is correct. And once confirmed, we process with the erase and write. And the flashing process will take a few minutes, and once it's completed, you can see the confirmation message like this, and then click Finish. And now remove microSD card from our card reader and insert it into the Raspberry Pi 02W. So now we are ready to power on our Pi and connect it through SSH. To take a first look at our camera connection, we start by opening a terminal and using the SSH command, and following with the username @ and hostname.local. When prompted, we type yes to confirm, and then once authenticated, you'll be logged into the Raspberry Pi through the SSH connection. And you'll see that the system looks extremely minimal, unlike a typical desktop OS. So next, let's do a quick check to confirm that the camera is properly connected. So we use the command ripcamera-hello with a list cameras flag. And once executed, you will see a list of available cameras along with its sensor details and the supported resolutions. And this confirms that our HQ camera connection is working as expected. And to verify what the camera is actually seeing, we need to go one step further. So now open two terminal windows. In the first terminal, we SSH into our Raspberry Pi as we just did. And in the second terminal, we stay on our local macOS machine. So what we want to do here is to stream the video frames from the Raspberry Pi Zero to our local macOS machine. And using the command ifconfig en0, which will display the IP address of our local laptop. And next we switch back to the Raspberry Pi's terminal and copy-paste the following command. And to stream the video frames from our HQ camera to the specific IP address we've confirmed of our macOS. And to receive this video frame on our macOS, we're using a command line tool called ffplay. And for simplicity, we're just going to accept frames from any source IP as long as they are arriving on the same port. Now we'll execute the previous command on the Raspberry Pi, and you'll see this log output indicating that the stream has started. Now if we execute ffplay command on our macOS, you will see a window popped up which showing the live stream directly from the Raspberry Pi Zero. And in my case, the camera is positioned in front of the 3D printer, and the stream is smooth and stable as expected. However, we're not going to manually copy-paste these long command lines every time we want to use this video frame. So next, we are going to simplify this workflow and make the camera streaming much more convenient and reliable. And the tool we're going to use is called mediaMTX. And mediaMTX is an open source media server that efficiently handles real-time video and audio streams. And in our case, we're going to use this Linux ARM 64 V8 version. So we navigate to the releases page and found the specific version we are going to use. On our Pi Zero, we use the wget command and copy-paste the link of the compressed distribution we want to use. In just a few seconds, you will have the mediaMTX distribution downloaded on our Raspberry Pi Zero. And then use tar command with xzf flags to extract all the resources. And now our mediaMTX has been successfully unpacked and ready to use. And firstly, we need to edit the mediaMTX.yaml file to configure the HTTP endpoint that we will later access from the web browser. Use the vi command to edit this mediaMTX.yaml file. And use the !pass to search the pass section. You will see it's at the end of the file. So here we copy-paste the snippet of code from the documentation. :w to write in, and :q to quit. So now we've finished writing the configuration YAML file, and we are ready to test the mediaMTX stream from our web browser. Then run the ifconfig command to check the IP address of our Raspberry Pi Zero. You could take a memo of this IP address or just simply open another terminal window and connect it to the Raspberry Pi again through SSH. In the second terminal, we will manually execute the mediaMTX binary to start stream video frames. And once executed, you will see this log output indicating that our server is running and ready to accept connections. Now open our web browser and copy-paste the full URL with our Raspberry Pi's IP address 192.168.11.5. Press enter. You will see a beautiful live stream in the entire browser. The video frames is smooth and the window is also fully resizable. So at this point, you can take a little break and adjust your camera lens or the lighting conditions, or just reposition your camera in a better place. And before we move on to the next step, I highly recommend to enable this source on demand config in our mediaMTX YAML file. And this configuration setting ensures that mediaMTX only requires the camera when there is a client actually requests the stream, which helps reduce unnecessary usage. To do so, use the vi command again to open the YAML file and jump directly to the bottom and add this source on demand line of code in our path configuration section. In the same way, :w write in and :q to quit. So now our mediaMTX is perfectly configured. But we're still facing a tiny limitation that if the Raspberry Pi is rebooted or powered off, our mediaMTX will not start automatically and we have to launch it manually every time. To eliminate our manual operations entirely, the next step we're going to do is to register this mediaMTX as a system service in our Raspberry Pi OS. To achieve this, the first step we're going to do is to move the mediaMTX files into the standard system locations. We start by copying the mediaMTX binary into the system's binary directory and the mediaMTX.yaml configuration file into the system configuration directory. And next, we navigate deeper into our system's service directory. And here, if you use the ls command to list contents, and you will see a number of existing service files already built by the system. And here we're using sudo vi command to create a new service file called mediaMTX.service. And inside the file, we paste the following snippet of code. And here you can see in the unit section, we specify that the service to start only after the network is fully available. And secondly, in the service section, we define the command used to start our mediaMTX along with a restart policy. This ensures that if the service crashes for any reason, it will automatically restart after 5 seconds. And finally, in the install section, we configure service to start when the system reaches a boot state where the network is fully available. And now the same way is :w write in and :q to quit. And at this point, our service file is completed, but it hasn't been activated yet. To actually start our service, we're going to use a command line tool called systemctl. Firstly, through the status command, we can see our service is loaded, but it's still not active. Next, we use the enable command to create a system link that allows our mediaMTX to start automatically at boot. Then, we use start command to actually start our service. And finally, to confirm everything is working correctly, we run the status command again. From the output, you can see the service is loaded and activated, and it's running and serving the mediaMTX as expected. So now we can exit our SSH session and return to our local machine. And without previously running anything, we just simply enter exactly the same URL we previously used. and you will see exactly the same live stream as when we started mediaMTX manually. And congratulations, we are almost at the end of today's setup. And so far, everything we've done works within the local network using our home Wi-Fi. However, our final goal is to access this camera stream remotely from anywhere. So in our final step, we will introduce a VPN and place both the Raspberry Pi Zero and our personal devices on the same virtual private network. And the VPN service we are going to use is called Tailscale. And start by searching for Tailscale and open the official documentation for installing Tailscale on Linux. And now SSH back to our Raspberry Pi Zero, and then copy-paste the command that downloads a specific shell script to install Tailscale on our system. And after the script finished running, the next step is to bring our Raspberry Pi Zero to our Tailscale network. And running the command sudo tailscale up, and you will be prompted to log into your Tailscale account. And you can authenticate using any supported method, and in my case, I'm using my Google account. And once you sign in, you will see the device connection page and verify the hostname is correct. In my case, it's A1 camera, and then click connect. And after that, you will be navigated to this Tailscale dashboard where you can see the Raspberry Pi listed as an active device in your private network. And one thing that I didn't show you in detail is that you also need to install the Tailscale mobile app on your phone to complete the setup. And once you log into the app with the same account, the process is exactly the same as we've done on the laptop. And here in my case, I log into the Tailscale iOS app and connect my iPhone to this virtual private network. And our camera's IP address in this VPN is also listed up here. And copy this VPN IP address and open any web browser on your phone and enter the same mediaMTX URL we've been using with this specific VPN IP address. And there you have it. The stream loads smoothly and works exactly as expected. And you can now preview the live stream directly from your mobile device securely from anywhere at any time. And that brings us to the end of today's video. And I hope you find this walkthrough helpful, and even if you don't have a 3D printer, and this setup can also work perfectly as a secure home camera system. And if you have any questions, feel free to leave a comment below. And thanks for watching, and we'll see you in the next one.